So here we have, well, if you all look here, it's definitely a triangle, right? For part one, we're going to try to find the radius of the circle. If, I'm just saying, if I were to take a line and bring it straight down, so it made a right angle with this line, you'll realize, well, this length and this length would be the same, because from here to here is the radius, and from O to A is another radius. Now, obviously, two radius are going to be the same exact what? Length. So this makes it an isosceles triangle for sure. Now, the thing about isosceles triangles, if you drop a vertical line, it is always split the underneath in two exact pieces. So here's what I'm going to do. I am going to draw only 1/2 of the isosceles triangle. So I have the point O here, and then it went straight down, right? And then it went across the B. Right? Quick question. Well, we know here is the right angle. What's the distance? I'm just going to call this point K. I know that we don't have a letter for here, so we're just going to call it K. Who can tell me, without any major calculation, what's the distance from K to B? Amaya, correct, right? Don't overthink it, don't overthink it. It's definitely going to be what? 6 centimeters. Another quick, easy question. How much would be this angle? Stefan, correct, right? Cassidy, correct. One more answer here. It's definitely going to be 40 degrees because we're cutting the angle in what? Half, okay? So here's what? Remember, the radius is from O to B. So think about it. Aren't we trying to find this distance here? Well, I should call it R, right? Because R stands for radius. So let's call it R, then just to make life easier, right? So what we can do now, right, is use either sine, tan, or cosine to find the value of R. You think you all can figure out which formula it is there? Let me help you a little bit more. If you're standing up in this angle, the 6 is the opposite to it. And the R, well, he's definitely the hypotenuse. So you're looking for a formula with opposite and hypotenuse. Which one would that be? Opposite and hypotenuse. Right, well, let's just go back to the formula sheet here. I think I have it somewhere here. Yeah, I think sine is the one. Look at it here. Sine is definitely the one with what? Opposite over hypotenuse. So in the exam, you're going to have to put down the formula for the examiner as at least, right? So sine theta is the opposite divided by the hypotenuse. And we're trying to find the hypotenuse. So to find the hypotenuse, you take the opposite and divide it by what? Sine. So you think you all can find R there for me? Right? I think I had worked it out wrong just now, right? So R is the hypotenuse. To find it, you have to take the length of the opposite and divide it by sine of the angle. The opposite is 6 centimeters and theta is 40. So to find R, which is your hypotenuse, is 6 divided by sine 40. Send that answer across and you will have the radius. 6 divided by sine 40. Make sure your calculator is set on degrees. Keisha, your answer will be in centimeters. Abigail, do not round it off to a whole number, right? They even said to go to 2 decimal places. So I think even without the examiner telling you anything, your first go-to is 2 decimal places. Now, when I work this out, I am getting it to be 9.33 9.33. I type it in straight. 6 divided by sine 40. So 9.33 centimeters. So that's the radius. You can even put it in on this diagram here if you want. 9.33 centimeters. Right, so we have part 1 finished. Now we're on to part 2. The area, right? The area of the minor sector AOB. That's the pizza slice, right? Now, if you use the hard sine rule, you should get the same answer. I'm not too sure. I just went with this method, right? So, Cassidy, if you got roughly the same answer, you will get the correct. Right? But to me, once I see the opportunity to work with a right angle, I just go to that. I find right angle triangle is just easier to do it. Okay, so the area of a sector. Now the sector is the whole pizza slicer that's including the curved part. So this is what we have so far. Here's O, here's A, and here's B. And they want us to find the area of the pizza slice. And it was so nice of the examiner to give us the angle of 80 degrees. What we had to work to find out here was 9.23. In case you cannot remember how to find the area of a sector, good news is it's given on the formula sheet. But I have it written down here as well. Let's see if I have it. Look it over here. I know it's kind of hard to see on this document here, but the area of a sector, the sector, that's the header. It's pi multiplied by the radius squared multiplied by the angle divided by 360. So let me write it back here. The area of a sector is pi multiplied by radius squared. We have the radius. Let's make sure it's squared. Theta is the angle living inside the sector and always divided by 260. You all can more than find the area of that sector. When I worked it out, I got this. Area as, try it back, Ashrina. Ashrina, you forgot the squared button here. I'm pretty sure about that. 60.77 centimeters squared. Try it back, Rhonda. It's pi multiplied by 9.33 squared, right? Right. So if you got it wrong, not a problem. Just clear your calculator. You know, just try it back, right? I'm sure it's just something simple you're mistyping on the calculator. All right. So for part 3 now, we want to find the area of the shaded region. Now, if we know the area of the whole sector, right? And if we were to find the area of the triangle, right? If you minus the area of the triangle and the sector, you will be left with the shaded region, which is what they want you to find, right? I think everyone can agree with that. So this is what you're aiming for now. We have the area of the whole sector. You just need to find the area of the triangle, that's the yellow part here, and minus it from the area of the whole sector. To find the area of the triangle, there's an easy way and there's a hard way. The hard way would be to say base, the base is 12, but tell me something, do we have the vertical height? Remember, the 9.33 is not the vertical height. That's the slanted height. The vertical height is the red line. From the looks of it, do we have the vertical height? The answer is no, right? I mean, but there is a way to find the vertical height. But let's not waste time in the exam. Instead, there's another formula you could use to find the area of a triangle if you have the length of two sides of the triangle, which we do because we know here's 9.33, and the other side being another radius would be another 9.33, and this is 80 degrees. If you have two sides and the angle in between the two sides, then you can use this formula. I think we bounced up this already. It's a half AB multiplied by sine C, right? I'm not sure. Where, let me zoom in here, right? This is also given on the formula sheet, right? Where A and B are the length of the two sides, and C is the angle in between the two sides. All right, so you all think you can go ahead there and find what the area now? But write it back properly. Area of a triangle is half AB sine A and B are the length of the two sides, and C is the angle in between two of them. And like I said, that will be given to you in the exam. So I'll replace A and B with the length of the two sides. Let me type that in on the calculator. And I am getting roughly 42.86 centimeters squared. Now, to get the final answer, remember, we said once we get the area of the triangle, we would minus it from the full area of the sector. So the area of the sector would be 60.77 minus the 42.86. I'm running out of space here, right? So let's write it over. 60.77 minus 42.86. And I am getting roughly 17.91 centimeters squared. Yeah, Nadira, I don't have a real long formula to find the area of a triangle. Now, if you have all three sides, but to be honest, I just stay away from that formula. To me, it's such a difficult formula to use. All right, but you could if you want to. The examiner would. All right, so confirm it on your end, guys. Well, when you finally see that 17.91 on your calculator, not on my screen, on your calculator, right? So somebody just wants me to scroll up for a little bit, right? Just scrolling up there for a bit. All right, so let's move down, right? So here, well, most likely you're getting a question like this one over here, right, for the exam. Right, so this falls under the geometry, right? Circular geometry. The information, I know piece of the sentence is cut out here, but that's not really too necessary. Is once you could see the diagram, right? So I just want to zoom into the diagram, and you all have 4 angles to find for me. 1, 2, 3, 4, and BEO. Even though whenever they give you 3 letters, it's always the middle letter they are referring to. So let me just show you which one is BEO. BEO is this angle. So everyone concentrate on finding this angle first. Sorry, try. A mistake here, guys. They said BEO. It's the middle letter. BEO, so it's this one. My mistake. Yeah, sorry guys. It's everybody corrected. All right, so the answer is supposed to be 52. Now let me explain why. For this, we're using Rule 5. Remember, in the exam, you're going to have to memorize this sentence, write out this rule, and then calculate the answer for the examiner. Rule 5 says the angle between a radius and a tangent is always 90. Now, O is the center of the circle. So that from O to E is definitely a radius. And this line here is your tangent. So the angle between, I said, well, where do I have some extra space? It's kind of hard to see with all of those lines. So from O to E, and then you have what? This line. It's supposed to be 90 degrees, but then it have a little slanted line here, and they're telling you that this angle is 38. So if the whole thing is 90, then this part here, the one they're asking for right now, won't that be 90 minus 38? And that will give you 52 degrees. So it's 52 because of this rule over here. Right, so for those who got it wrong or didn't submit an answer, let's confirm with me that, hey, you understand it now, right? Don't stay silent in class. Exam is right around the corner. Now is the time to be interactive in class. Right. Right, so the next one, we get some different colors because this is going to get pretty complex. B, C, E. So B to C to E. Part 2 is asking for this blue angle here. Right? I'll give you a hint, right? O to E and O to B are both radii. So that means OB and OE have the same length, which means OBEO, that's an isosceles triangle. Use that to help you out. So we want this blue angle here. Now there are two ways to get this. I'm going to do the long way first, right? And then we'll do the easy way because I didn't see the easy way first. So if this is truly an isosceles triangle, if here is 52, then over here would also be 52. All the angles in a triangle add up to how much? 180. So we can more than calculate this angle here for the time being. So we add 52 and 52 and we minus it from 180. So 52 plus 52, minus it from 180. And I think over here, we're going to get 76 degrees. I'm pretty sure that that's the answer for this part. But remember, the examiner is asking us for this angle. Let's go back to the rules and see which one we can use. Of the rules here, we have to use, it looks like it's going to be rule. That's okay. That's another trouble. Right, going to move. Rule 2, right? So rule 2 is basically saying that if you have an angle starting at the circumference, if it hits the center and bounces back to the circumference, you must have an angle. If you have another angle starting at the same place, but this time hitting the circumference and bouncing back, the one at the circumference is always half the size. So if the one at the center is 120, the one touching the circumference will be half that, which is 60. So, great. So, if we look at, we have the same scenario over here. E hitting the center and bouncing back. But this one up here is hitting what? The circumference. He's half the size. So how much is half of 76? 38 degrees. Right, so he will be 38 degrees. This one was how much? 52. Right. Remember, you're dividing this by 2. The one at the circumference is the smaller one. So do not multiply by 2. You are dividing by 2. Right. The next one is BAE. Where's that one? Right. BAE. That's this angle here. Do not overthink that one, right? I'll give you a hint, right? It will be rule 4. Let me show you a rule. It's kind of hard to get this. I'm trying to get all the rules. Rule 4 is down here. Rule 4 is the one with the cyclic quadrilateral. The opposite angles in a cyclic quadrilateral add up to 180. But for it to be a cyclic quadrilateral, all corners must touch the circumference, the four-sided figure. No? So you gotta be careful. Huh? Quick question is, there are 2 things that look like a cyclic quadrilateral inside here. Is EOBA, is that a cyclic quadrilateral? Look at it. EOBA. The answer is no. E is touching the circumference, A is touching the circumference, B is touching the circumference, but O is not. The cyclic quadrilateral is actually from E to C to B to E. That's the cyclic quadrilateral. Let me draw that back properly so you can see it. Okay. But all those lines, it really gets tough to focus on just what you need. Right? So here's A, which is what the examiner wants you to find here, right? That's our, he wants, sorry, over here, BAE. We know that this side here is 38. Opposite angles must add up to how much? 180. So how much is A? 180 minus 38, and I'm getting 142. 142. Because 142 plus 38 is 180. All right, so we just have one more to find, guys. BOE. But we found BOE already when we were trying to find it. But we have it here. BOE. BOE is 76 degrees. We already had it from working out a previous question. All right, so I'm going to leave that on the screen just for a few seconds. Look, we have a nice question here. Now zoom out. Let's see if I can make it fit. Yep, we can make that fit. 7 marks for this part B. Good luck. It wants you to find the distance MT. So I extracted the kind of interior triangle, MTN. Isn't it very easy to reason out this angle? Because a straight line is 180 degrees, right? So if here is 65, isn't it possible to get this angle? Let's get that out of the way first. How much is that angle? That angle is, let me see, 180 minus 65. I am getting 115 degrees. Great. Now, this is definitely a non-right angle triangle. So when we're doing this question, it's either going to be what? The hard sine rule, sorry, the sine rule or the cosine rule, right? It's going to be, let's see. It's going to be this one over here. The A on sine A is equal to B on sine B and C on sine C, right? If yes, T, well, oh, sorry, you notice we have 3 angles here, right? Sorry, 2 angles, 115 and the 42. Let's just find this angle and get it out of the way, because all the angles in a triangle add up to 180 anyway. Right? So somebody tell me it's 23, but another out here. Let's double check it. Let's double check it. 23 degrees. All right. I'm not saying we will need the 23, but we might as well find it. It's so easy to find and it might be helpful. So if here's capital T, over here is common T. If here's capital M, the opposite side is common M. If here's capital N, over here is common N. Okay? We are trying, which letter are we trying to find? We're trying to find MT, that's common N. When we're using this rule, right? Well, when we're using the sine rule, remember we just have to throw away one of the letters. Which letter are we going to throw away? The N, the M, or the T's? Which one? No problem, Nadira. A lot of people are saying it's M, and you all said that so fast, which is good. Because we want to find common N, and we have capital N. We have common T, and we have capital T. We don't have as much information on M's. So it's N on sine capital N is equal to common T on sine capital T. Common letters represent the length of sides, but capital letters represent the angles. Fill in what you have and cross, multiply, and solve for common N. And the examiner told you that you're supposed to get something close to 26 when you round it off to the nearest whole number. Right, so answers are coming up. Right, so common N was, that's what we're trying to find, sine capital N. Remember, it's 42 degrees, that's capital N. It was common T divided by sine capital T. Right, so it turns out we did need the 23 degrees. Now, there are plenty of ways we could find sine 42 first, and then sine 23, and then cross multiply, or we could cross multiply one time and sine last. It really doesn't matter. Right? N multiplied by sine 23, and that is equal to cross multiply the other diagonal, 15 multiplied by sine 42. Whenever you cross multiplying things like sine or cosine, make sure, like if you have 15, make sure the 15 comes first and then the sine 42. Huh? That's very, in other words, don't type it in like this on your calculator, because what your calculator will do sometimes, or depending on the calculator, it will multiply the 42 and 15 first and then sign it. You don't want that. You only wanted to sign 42 and whatever you get, then multiply by 15. Okay, you have to know those little things. And then, well, you want to solve for N. So the sine 23 is a multiply. Throw it across, you get what? A divide. Right? So let me type in this on my calculator and see what I get. 15 multiplied by sine 42, press equal, and then divide by sine 23. And I am getting 25.69, which is approximately 26 meters. Right, so make sure you see something very close to this. You might get something slightly different, like 25.8 something or 25.7 something, 25 point anything. Right, so when you get that now, hence calculate the height of the tower TL. They want this distance here. Now you're going to have to use this answer to get it. Now, well, once again, right? If you have to use this answer to get part 2, they didn't tell you which one to use. They didn't tell you whether to use the 26 or the more accurate answer, 25.69. I like to be accurate, so I'm going to use this value. If you use this in the exam, the 26, I cannot see the examiner minusing any marks from you because he didn't specify which one to use, right? So any reasonable examiner keyword, reasonable, not supposed to take away points for that. All right, so let me help you out a little bit. Let's only focus on this triangle. So let's go back up over here to the green triangle. Remember, we just found MT. MT was how much? Roughly 25.69. So MT was 25.69. We know here is 65 degrees, and I want you to find this length. Look how easy this is. This is a regular, boring, right angle triangle. They want you to find over here. So you figure out whether it's normal sine, tan, or cosine. This is the angle we have. This here is the opposite side for sure. And this here is definitely the hypotenuse. So this is opposite and hypotenuse again. So it's sine once again. Sine theta is opposite over hypotenuse. And we're trying to find the opposite side. So how do you find the opposite side? Hypotenuse multiplied by sine theta. Right? So the opposite side is hypotenuse multiplied by sine theta. Well, we have all the information here. Let's type that in and finished. And I'm getting roughly 23.28 for the height of that tower. To get something slightly different, don't let it bug you, but 23 point something. As some of you all might have used the 26, the approximated value. In part one, they ask you for something called the angle of elevation. Now, they said the angle of elevation of you from S, which means we are standing at S. Angle of elevation is when you're facing forward. So if at S, you're facing forward, and then you tilt your head upwards. So you're rising your head, like you're making your chin go upwards until you see the point U. And elevation means to move your head upwards. So they're really asking for this angle. I know they're being difficult. They could have just said, find angle RSU. How much is this angle? Real straightforward. A straight line is 180 degrees. It's obviously 60 degrees, right? They just minus it from 180. So that is the end of that part, right? Now they want you to find the length of UT. That's this line here. And they said ST was 15 meters. So I kind of put it in on the diagram here. They only said it, right? They didn't write it in on the diagram. And just like the previous question, all the angles in a triangle add up to 180. So we can more than find this angle, even though we mightn't use it. Let's just find it just in case. How much is that angle? 120 plus 40 minus it from 180. That's the 180. This one. I'm getting 20 degrees over here. And they ask us to find UT. Let's put in our common letters. This is a non-right angle triangle. So it's either going to be the hard sine rule or the hard cosine rule. Here's common S. Here's common T. Here's common U. We're trying to find UT. That's this guy here. Who are we going to throw away? This is the hard sine rule. We're throwing away US or the T. Yeah, I agree also, the T. So we keep in the U's and the S. So U divided by sine capital U is equal to common S divided by sine capital S. You see how in the exam I'm making the common letters ridiculously small and the capital letters ridiculously big. So that is so you don't mix up anything. Right, so get started. Amanda, see I have an answer. Right, so let's cross multiply here. You have S multiplied by sine 20. And then what? 15 multiplied by sine 120. You want to solve for s. This here is a multiply, throw him across, you get a divide. Right? Put a little arrow like that in the exam. Let's see what we get here. 15 multiplied by sine 120 divided. Right, and you all are correct. We are getting 37.98 meters. Right now, you will get a slightly different answer if you see how I cross multiply and at the end of the day, then I type in the signs, right? But if you find sine 20 and round it off, then find sine 120 and round it off, and then cross multiply, well, you're going to get something slightly different. The examiner is not going to mind. Just make sure when you find sine 20, go to 3 decimal places. When you find sine 120, go to 3 decimal places, cross multiply, do everything. And at the end of the question, round off the 2 decimal places. All right, so let's go to this other scary question now. This one here. Oh God. Just looking at this, looking like it's going to be pressure. All right, so get started with this one here. You have 4 angles once again to find. Oh, sorry about that, guys. I was on mute just now, but I made a slight mistake. I didn't finish the question. We're supposed to find RU. So we just found UT. So I'm going to use the big triangle now. If we use the big triangle and here's 40, well, this side is opposite and here's the hypotenuse. This looks like a sine question again, because sine theta is opposite divided by hypotenuse. To find the opposite side, we take the length of the hypotenuse, which is 37.98, and multiply by sine 40. Let's see what we get there. 37.98 multiplied by sine 40. And I am getting 24.41. Right. All right, so sorry about that, right? But this question was almost identical to the previous question. All right, so let's move on back to the scary question, right? SON, SON. That's this angle over here. Remember, O is the center of the triangle. I'm gonna give you a next hint. You notice they're going from S to the center and bouncing back. Then you have another angle going from S to the circumference and bouncing back to N. So both of them start at S and end at N. One going to the center and 1 going to the circumference. That looks like rule 2. The one at the center is always be twice as large. The center one is the larger one. So Rhonda, correct. Anybody want to take a shot at it? How much is this? SON. Amanda, correct. Cassidy, correct. Anaya, correct. I'll take one more answer. Right, Sanjana, correct. And Samara. That looking like, if here is 35, then over here should be twice the amount. So it's going to be 70 degrees. Right? You see, it wasn't straightforward like how the rulers look in the book, because this line and this line overlapping each other. But the point is, one going to the center and one going to the circumference. Okay. What's the other one? NMQ. What Q is quite up here. Okay, NMQ. Even I get worried about this question, right? I need some time to think on it. Like I said, we're going to use rule 1, right? So if both of them standing on the same arc, well, the angles are going to be the same. So I think you're seeing that here. S to P to N, and then SQ back to N. So if here is 35, then this guy over here is 35. Now, O is the center of the circle. So from here down, here is a radius from O to N, and then we have a tangent. The angle between a radius and tangent is always 90 degrees. So you all see a big triangle here. It's a right angle. It just happens to be a right angle triangle. M, Q, N back to M. And all the angles in a triangle add up to 180. Right? So you have to show the examiner after you write back rule 1 and you write back rule 5. Right? You have to say, and remember, this is not the angle QR. Don't refer to this angle as QR. His name is MQN. Don't use one letter to specify an angle, right? And then when you get the 35 and the 90, show the examiner that you add the 35 and the 90 and minus it from the 180 to get 55, right? Don't leave out any word, any word. And pretend you're writing a textbook, a real good textbook explaining the answer. All right, no problem, Jordan. Right, so PLN. Right, so someone, okay, while you all try PLN, someone just wanted a re-explanation. I'm not too sure if there's a word for angle SON. I was using rule 2 for that one. One of SON is touching the circle, the center, and SPN is going to the circumference. The one at the circumference is the smaller one, and the one at the center is be twice its size. So it's rule 2 I have used. Right, so let's get to the view here. Right, one going to the center, one going to the circumference. All right, so PLN. Let me see what that one is about. Oh Lord, down here. It's this angle here. All right, so part 3, right? It took me a while to see this because it just has so much lines on this diagram here. But if you look carefully, right? LON. Let me just concentrate on that. L to O, where's the center of the circle, back to N. Remember, here's 90 degrees. That is this guy here. And we know here's 70. And the examiner for part 3 is asking us for this angle. So it was just a matter of adding the 70 and the 90 and minusing it from 180, because all the angles in a triangle add up to 180. And we would have gotten how much here? 20 degrees. All right. So, right, so I was overthinking that one. So over here is 20 degrees. Now for part 4, SNM. That's this angle here, this purple angle over here. Now it took me a while, right? But then I was thinking back to my rules, and let's look at rule 7. Now, rule 7 is basically saying this. If you have a circle, and in the circle, you have a chord, right? So we have a chord. And then one side of the chord must touch the circumference. Let's say we have a tangent here. There must be an angle between the tangent and what? The chord. If you have an angle starting at the beginning of the chord, hitting the circumference and bouncing back, right? The angle underneath the chord and the angle standing on the chord and touching the circumference, there's always be the same. When you're writing back the rule, do not write basement and article. That is what I call the rule, but no textbook calls it that, right? So that means, look at it here. This come like the chord, C-H-O-R-D. This is the chord, and you have a tangent. You have an angle between the chord and the tangent, and then you have an angle standing on the chord and touching the circumference. So if here is 35, then over here is also 35. Right? But like I said, you have to write back the rule first for the examiner. Right? The one underneath the chord and the one touching the circumference, there's always be the same. All right, so it was. Remember, it's 2 circles. One has a radius of 5 and one has a radius of what? 2. So obviously this is the one, the bigger circle has a radius of 5. So, I mean, from here to here is 5, from the center to here is 5, but basically the center to the circumference. So doesn't that mean from P to T is how much? 5? And then for the smaller circle, its radius is how much? 2. So that means the total distance is 5 plus 2, which is 7 centimeters. For those who got it wrong, you understand, right? And I'm going to clean it up for you here a little bit, right? Total distance will be 7 centimeters. 5 plus the 2. All right. So part C. Why is PS, so let me get a different color here so it'll be easier to see. Why is PS and QR parallel? Believe it or not, it comes back to this rule over here. Rule 5, right? The angle between what? The center, sorry, between a radius and a tangent is always 90 degrees. Look at it. This is a radius and this is a radius. So both of them, because of rule 5, which you have to write back in the exam, right? You have to say that the angle what? Well, the name of this angle is RSP and the name of this angle is SRQ. You have to write the rule and then say both angles are 90 degrees. So if both, and that will be the end of it, right? The examiner will put the rest together. Part 2. Right, so here's where the calculation starts. Right. So what they're really trying to say over here is that N is the same height as from, you see, from here to here to here is the same distance. Both of them have the same distance. That's the only reason it would be parallel. So remember, Q to R, its radius was 2 centimeters, but PS S, that radius, the whole thing was how much? 5. Isn't this a rectangle here? The opposite sides of a rectangle have the same length. So if here is 2, then from N to S is also 2. But they want the distance from P to N. If the whole thing is 5, and this little piece is 2, how much is Pn? Right, everybody is getting it correct now. Pn will be 3 centimeters. So here's 3. Look how easy RS is going to be now. RS is this distance. But the opposite sides of a rectangle have the same length. So that means if I were to find the distance NQ, if I were to find this distance here from N to Q, I would automatically be finding from S to R. So let's draw back that triangle here. Here's Q, that is this guy. Go back to N and then go back to P. We know here's 7. We just reasoned out here's 3. This is definitely a right angle triangle. Couldn't we use Pythagoras Theorem to figure out this length here? No, somebody said, no, RS. RS is not the same distance as PQ. PQ is the slanted distance. We're trying to find NQ, which I think we could use Pythagoras Theorem to figure out. Are we going to use the one with the addition, or are we going to use the one with the subtraction? We're talking about Pythagoras Theorem here. Cassidy, wrong. Amanda, correct. Remember, if we, okay, let me look back at this. PQ is what? The hypotenuse. Everyone agrees with that, right? Because it's opposite the right angle. Anytime you're trying to find the hypotenuse, because the hypotenuse is so special, it is usually one with the addition. That's how you just remember it. The other 2 sides are regular boring sides. You just call them legs. Anytime you're trying to find a leg, it is usually one with the minus sign. So if you're trying to find NQ, right? You have to take the hypotenuse, which is PQ, but you have to square it, and then minus the other leg that they give you, which is PN. All right, so make sure, guys, for the exam, you don't mix it up. If you're trying to find the hypotenuse, this would have been an addition. If you're trying to find a regular boring leg, it's a minus. So you all can more than work this out now. 7 squared minus 3 squared, work out this first and then square root the answer. Let's see what you get. I am getting the same thing as you guys, 6.32 centimeters. And of course, NQ and SR have the same distance, 6.32. And that's it.